and Vij are vector loadings. PCA versus FA. PCA is from x to z. You can see here the formula is z equals to wt into x minus mu, and factor analysis is from z to x. You can see here the formula is x minus mu equals to v of z plus epsilon. Here the variable is x and the new variable is z. Here the variable is x and factor is z. In FA, that is factor analysis, factors Zj are stretched, rotated and translated to generate x. You can see there is a circle, but it is stretched, rotated and translated to generate x, as in this figure. Multidimensional scaling. Multidimensional scaling is used to translate information about pairwise distances among a set of n objects or individuals into a configuration of n points mapped into an abstract Cartesian space. The Dij, where ij equals to 1 to n, placed on a low-dimensional map, distances are preserved. Z equals to g of x given theta. Find theta that has the minimum summation stress. E of theta given x equals to summation of r comma s, where mod of z to the power r minus z to the power s minus x to the power r minus x to the power s to the power of 2 divided by mod of x to the power r minus x to the power s square equals to summation of r comma s mod of g multiplied x to the power r given theta minus g of x to the power s given theta minus mod of x to the power r minus x to the power s to the power whole square divided by mod of x to the power r minus x to the power s whole square. You can see this is a map of Europe over here, and this is represented by MDS algorithm with grids and all. Linear discriminant analysis, LDA, is a generalization of Fisher's linear discriminant, a method used in statistics and other fields to find the linear combination of features that characterizes or separates two or more classes of objects or events. The resulting combination may be used as linear classifier or more commonly for dimensionality reduction before later classification. It finds a low dimensional space such that when X is projected, classes are well separated. Finds W that maximizes JW equals to m of m1 minus m2 whole square by s1 square plus s2 square, where m equals to summation t w to the power t x t r t by summation t r to the power t s1 square is equals to summation t of w to the power t x to the power t minus m1 whole square multiplied by r to the power t. Here in this diagram you can see the x-axis is x1 and the y-axis is x2. Here is a line going from this origin, and this basically shows the LDA projection, that is maximizing the distance between the two groups. You can see that M1 is the distance S1 square and it's M2, the space is S2 square. It separates the distance between the two groups. and this is basically the W, that is this one. Between class scattered and within class scattered. Begins with between class scattered. M1 minus M2 square equals to W to the power T of M1 minus W to the power T of M2 whole square, where taking out WT, multiply M1 minus M2, multiplied M1 minus M2 to the power T, W equals to W to the power T SBW, where SB equals to M1 minus M2 multiplied M1 minus M2 to the power T. Within class scattered is S1 square equals to summation T W to the power T of X to the power T minus M1 whole square of R to the power T equals to summation T of W to the power T X to the power T minus M1 of X to the power T minus M1 to the power T of W R to the power T equals to Wt of S1 of W, where S1 equals to summation of X to the power T minus M1 multiplied xt minus M1 to the power T of R to the power T. S1 square plus S2 square equals to Wt of SW multiplied W, where SW equals to S1 plus S2. Fisher's linear discriminant finds W that is maximum. G of W equals to W to the power T SBW by W to the power T SWW equals to mod of WT of M1 minus M2 to the power square whole square actually, divided by W to the power T SW of W. LDA solution gives W equals to C multiplied by S W to the power minus 1 of M1 minus M2. The parametric solution W equals to, if summation to the power minus 1 of mu1 minus mu2 when P of x given Ci tends to n of mu I, comma, summation. K greater than 2 classes. Within class scattered, SW equals to summation where I equals to 1 to K SI. SI is equals to summation T Ri to the power T of x to the power T minus Mi multiplied by xt minus Mi to the power T. Between class scattered is SB equals to summation of I to the power K Ni multiplied by mi minus m into mi minus m to the power t, where m equals to 1 by k, summation I equals to 1 to k of mi. Find w that is max. Jw equals to mod of wt sbw divided by wt sww. The largest eigenvector is of sw to the power minus 1 of sb and maximum rank of k minus 1. This graph shows the op digits after applying the LDA techniques, and see lots of scattered point. This is 0 and this is a negative side and this is a positive side. This 0 comes here. This is the negative sides and this is the positive sides. You can see the number scatters are more over here in the comment. This talks about 7 points, 4 points of 4. Actually, these are the groups 4, 7, then 6. You can see zeros, twos, fives, but at this point there is a scatter, like lots of points are together in the center. Isomap. Geodesic distance is the distance along the manifold that the data lies in, as opposed to the Euclidean distance in the input space. You can see from this to point, the Euclidean distance is this, whereas the geodesic distance is this one. Instances R and S are connected in the graph if mod of x to the power R minus x to the power S is less than the error, or if x to the power S is one of the k neighbors of x to the power R. The edge length is this one. For two nodes, R and S are not connected. the distance is equal to the shortest path between them. Once the n cross n distance matrix is thus formed, use MDS to find the lower dimensional mapping. This is the op digits after isomap has been applied with the neighborhood graph. This is the 0 is the negative points and the positive points. This is 0 and the negative points and the positive points on y-axis. Locally linear embedding. Given x to the power r, it finds its neighbors x to the power s of r, finds WRS that minimizes E of W given x equals to summation r mod of x to the power r minus summation of s of WRS of xrs to the power s to the whole square, and finds the new coordinate z to the power r that minimizes E of z given W equals to summation of r mod of z to the power r minus summation s of WRS ZRS whole square. This explain about the x space and z space of the previously discussed slide. You can see this is XR and this is WRS. This is XS to the power R. This is XGXS, X1 and X2. But the z space is pretty simple. This is the Z1, Z2 axis. This is Z to the power R and this is ZS to the power R point. This explains the diagram of objects on applying LLE. So you can see in x-axis it has the negative point and um, the positive point on this side. This is a 0 and it's slightly different from the other graphs, and this is all 1 on the y-axis, and this is how it looks on applying LLE.